project, instead of creating entirely new, we choose to rediscover something timeless. Time is something we actually trap inside machines. For 3 centuries ago, one man believed time did not belong to the gears, it belonged to the entire universe. In the early 18th century, when much of the world were dependent upon the fragile mechanical clocks, Maharaj Savai Jai Singh II, the ruler of Jaipur, created different path. He was not only a king but a scientist, mathematician and astronomer. While studying Indian, Islamic and European astronomical texts, he discovered that many existing systems based on the fragile mechanical models and that were inaccurate. This belief pushed him to measure the sky itself, using precision, mathematics and nature as his guide. To bring his vision into life, he built the Yantra observatories in Jaipur, Ujjain, Delhi, Mathura and Varanasi. The name Jantar Mantar comes from Yantra means instruments and Mantra means calculations. These observatories use massive stone instruments chosen for the stability and long-term accuracy. Among all these instruments, one stood above the rest, that is the Samrat Yantra. At this point, a question arises, what is Samrat Yantra and what is the difference between the Brihat Samrat Yantra and Laghu Samrat Yantra? To explain it further and demonstrate how it applies to our working model, I would like to hand over to Brihat.
To explain the difference between Brihat Samrat Yantra and Laghu Samrat Yantra, first I would like to explain what is Brihat Samrat Yantra. The Brihat Samrat Yantra is the largest sun dial ever constructed by human hands. The original structure in Jaipur is almost 27 meters tall. Yet this massive stone instrument can measure time with an accuracy of 2 seconds. Think about that. In an age with no modern machinery, no computers and no electronics, such precision was achieved using only geometry, observations and vision. This achievement amazed scientists not only in India but all over the world, from Europe to Middle East. There are 2 forms of this instrument. The first is Laghu Samrat Yantra and the other is Brihat Samrat Yantra. The Laghu Samrat Yantra is a small, portable and is used for learning as it is a demonstration model. Brihat Samrat Yantra is a monumental, permanent design for extreme accuracy. While the Laghu version helps us understand the concept, the Brihat version pushes the concept to its scientific limits. Because in sundials, bigger size means higher precision. A larger structure produces sharper shadows, smaller measurement errors and greater reliability. This is why Jai Singh did not build small instruments. He built monuments to precision. Our model is a carefully scaled down version of the Brihat Samrat Yantra. The dimensions are reduced, but the proportions, angles and orientations remain unchanged. Which means when sunlight falls on this model, it behaves exactly like the original. Smaller in size, but identical in size. How does structure of Samrat Yantra actually works? Which part makes it measure time so precisely? I would like to call Tanish to explain it further.
Talking about the astronomical working of principle of the Samrat Yantra. The Laghu Samrat Yantra is a smaller version of Brihat Samrat Yantra, but it works on the same scientific principle even though it's smaller in size. It's highly accurate and designed astronomical instrument used to measure time using the position of the sun. The instrument does not depend on the mechanical clock. Instead, it works purely on astronomy, Earth's rotation and apparent movement of the sun. Talking about the usage and importance of the Laghu Samrat Yantra. Apart from measuring time, the Laghu Samrat Yantra was also used to study the daily and seasonal movement of the sun. By observing changes in the length and position of the shadow during the different months, astronomers could determine the sun's declination and understand the changes of season. Another major use of Laghu Samrat Yantra was the preparation of calendars and astrological calculations. Accurate time measurement was essential for religious rituals and festivals and predictions. Although it is called Laghu, meaning small, the Laghu Samrat Yantra played a significant role in observational astronomy. It beautifully shows how ancient Indian astronomers used geometry, sunlight and careful observation to achieve accurate scientific results. The Laghu Samrat Yantra stands as a brilliant example of a combination of science, mathematics and architecture. Now to understand the science behind the precision, let's move to the mathematics. Now I would like to hand over to Akash.
This constant rate of rotation is the mathematics foundation of Samrat Yantra. Now observe the gnomon, the tall triangular structure. Its inclination is not chosen randomly. The angle of gnomon is exactly equal to the latitude of the place. For the Jaipur, the latitude is approximately 26.9 degrees. and therefore the gnomon is tilted at 26.9 degree. Similarly, for Pune, it is 18.5 degree. The precise inclination aligns the gnomon parallel to the Earth's axis, allowing it to track the sun's apparent movement accurately throughout the day. Now let us look at the curved quadrants. Are the quadrants of Samrat Yantra. The quadrants are mathematically calibrated using trigonometric principles, the angular motion of sun and the earth's rotation rate at 15 degree per hour. As the sun moves, the shadow of the gnomon moves. Each movement of the shadow corresponds to the precise time intervals. There are no clockwork here, no gears, only geometry, angles and the sunlight. The brilliance lies in the scale of instrument. The larger the Samrat Yantra, the sharper the shadow, and the sharper the shadow, the precise the time. This is exactly why Maharaj Jai Singh constructed the instrument on the massive scale, not for the grandeur but for the scientific precision. Our model demonstrates the very same principle. Here, time is not read from numbers, it is not calculated by machines. In Samrat Yantra, time is not measured, it is observed. Now, to conclude, I would like to call Akshay.
To conclude, the Laghu Samrat Yantra is not just a model, it is a powerful representation of ancient Indian scientific brilliance. It shows how the time can be measured accurately using sun, shadows and precise mathematical design. Our model is based on same principle as Samrat Yantra built by Maharaja Savai Jai Singh. By aligning the gnomon at 18.5 degree, which matches the latitude of Pune, and positioning our model from north to south direction, we are able to determine local solar time through the shadow falling on the quadrant. This instrument proves that the centuries ago, Indian scientists had a deep understanding of geometry, trigonometry and Earth's rotation, achieving the accuracy better than early mechanical clocks. Today, the Laghu Samrat Yantra continues to inspire students and researchers by connecting ancient knowledge with modern science. Now, let's see. This slide shows the blueprint and our working model. Our working model are created with the proper measurements and calculations. This model is built with teamwork, guided by mathematics and powered by the sun. The Samrat Yantra proves innovation, it's timeless. Thank you to our team and thank you to all.